Now this one is a really major principle that sometimes you think about it and you say, well, I'm not sure we use that all the time, but we use it a lot of times and we just don't really stop to think about what we're doing. But it's called the principle of transmissibility. Now, let me show you what this means. Let's suppose that I have coordinate axis here. And so let's say that that's X and this is Y and this is Z. So I've got my general coordinate axis there. And then I tell you that there's some sort of rigid body floating out here in space. And just kind of work with me here. It's floating out there in space. And then acting on that rigid body at this point is a force. I'll just call it F. Like that. Now that force is applied at this point, and maybe I'll just say that that's point A. So this force F is applied at point A on this rigid body, which is stationary with respect to this coordinate system. Got it? Okay. Now, if that's the case, what I'm telling you about this principle of transmissibility is I can come in here and I can define the line of action of that force. And what I mean by that is I just imagine that that's an arrow. That's sort of what a vector is. And I just extend the tip on out in that direction and then back in this direction. And I'm telling you that for the problems that we're working, when we start to calculate reactions and all the things we're going to be learning how to do, I can take that force and I can slide him over here, or I can slide him here, or I can slide him here, and it won't make any difference at all. So the principle of transmissibility means that if I take that force, I can slide it anywhere along that line of action, and it will have exactly the same effect on this rigid body that it would if it was applied where I originally drew it. Now, like I say, we don't go around every 2 seconds saying we're using the principle of transmissibility, but once we start calculating moments about points and things like that, it's hidden. The concept of it is hidden into our thought process, and so it's a very fundamental principle that you need to get straight in your head. So you've got your vector addition, you got your principle of transmissibility, and then you've got your Newton's laws. And so those, if you kind of get a good handle on these concepts and the non-accelerating reference frame and understanding about vectors and things like that, you're going to do okay in the class.